Good evening. It is Sunday, and tonight we are doing something completely different. We're doing a bit of architectural drafting by hand. This is primarily for me to de-rust my skills, and I will do this by talking through the instructions I would give to any other beginning draftsman, which means this is your chance to learn or relearn along with me. To start, we will go over the tools you will need and also reasonable substitutes that one can use if you aren't sure you want to spring for all the formal supplies. This part may end up being the entire video for tonight, and any drafting might have to wait until next time. If you have questions, feel free to ask them in chat and I will answer them as I see them. So the first, most important, and easiest to substitute tool is the drafting board itself. This one is 2 feet by 3 feet in size and has a straight edge built onto it which is parallel to the long edge of the board. The back of the board, one moment. The back of the board has 4 pulleys and a wire attached to the straight edge. The spring here keeps tension on the wire. This wire and pulley system allows the straight edge to be moved up and down the board while still keeping it parallel, like so. There are also some knobs on the straight edge you can use to secure it in place. As I mentioned, it's reasonably easy to substitute for this tool. You will need a board of some sort with a very smooth surface. The drafting board itself has a melamine surface, but a mirror or a sheet of plexiglass or a very well-varnished tabletop would also work. It just has to be smooth and hard enough that the tip of your lead won't leave grooves in it. It is important that at least one edge of your surface be square and that the edge is not raised above the surface. For your straight edge, you can use a T-square. The cross piece of the T-square will go against the edge of, will go flush against the square edge of your surface, and you can hold it in place with clamps. I'm going to move the camera closer now to better show the rest of the tools. Please excuse the roughness of the movements. I ran out of time to practice them very well. That should be close enough. The second tool is a triangle. There are several options. This one is adjustable to various angles, which gives you a bit more flexibility to design things that your builders will curse you for. It can also be configured into a square. If you have an adjustable triangle, you'll want at least 2 more. A 30, 60, 90 degree triangle and a 45, 90 degree angle triangle, as the adjustable triangle can substitute for the second of the pair of either of those configurations. If you don't have an adjustable triangle, you will want 2 of each of the other triangle styles, matched pairs if you will. What this allows you to do is things like this, which gives you parallel edges. Where on earth is this camera oriented? Slightly better. There we go. That allows you to do parallel edges without moving the straight edge, which might be important to not move. Let's see. The third tool is an architectural scale. Which is this 3-bladed ruler. So the scale has a number on each end, which tells you the distance in inches between the marks which start from that end. This face, for example, has a number 1 on the left end and a number 1/2 on the right end. If you start from the left, you will notice that these long marks have ascending numbers on them, 0, 1, 2, and so on. These long marks are 1 inch apart, and each of them represents 1 foot on a scaled drawing. This is a 1 inch equals 1 foot scale, written thus on the page, and commonly called a 1 inch scale. If you start from the right end, you will notice that all the marks are 1/2 inch apart, and the short marks have ascending numbers but are counted by 2s, 0, 2, 4, and so on. Starting from this end, all of the marks, including the long ones, are 1/2 inch apart, and each one represents 1 foot on the scaled drawing. This is a 1/2 inch equals 1 foot scale, written thus on the page, and is commonly called a 1/2 inch scale. You'll notice at each end a set of smaller marks. On the left end, the distance that these marks divide is 1 inch in length and a foot according to the scale. The longest marks, which are numbered, represent 1/4, 1/2, and 3/4 of a foot, or 3, 6, and 9 inches, with this last one being 12 inches. The next longest mark represent the other inches, 1, 2, 3. The third longest marks represent 1/2 inches, and the shortest marks represent 1/4 inches. On the right end, the distance that these marks divide is a 1/2 inch in length and a foot according to a 1/2 inch scale. The longest marks, which are not numbered, again represent 1/4, 1/2, and 3/4 of a foot, or 3, 6, 9, and 12 inches. The next longest marks represent the other inches, 1, 2, 3. The shortest marks represent 1/2 inches, and the scale is too small to represent any distance shorter than that. The same holds true for the 1/8 inch and 1/4 inch scales. The 1.5 and 3 inch scales, the 3/4 and 3/8 inch scales, and the 3/32 and 3/16 inch scales. There is also a 12 inch ruler with 16th inch divisions on it. Which scale you choose depends on the size of the object or structure for which you are drawing plans and the size of your paper. The smaller your paper and the larger your building, the smaller the scale you have to draw at. This is one tool for which there is no easy or convenient substitute. It is purpose-built for making scaled drawings, and your drafting will be infinitely easier if you have one. This one is plastic with the marks printed on it, but you can also get metal ones with incised marks. The advantage of the incised marks is that they are harder to rub off than the printed marks, which, as you can see, are coming off the 1/2 inch scale. There is also an engineering scale, which is very similar to the architect's scale. But the divisions on it are in tenths of an inch, rather than halves, quarters, eighths, and 16ths. The engineering scale is used for drawings where 1 inch on the plan might equal 10 or 20 or 30 feet on the site, such as for road construction or other infrastructure plans. I confess I don't use one of these very often. It is much more useful for landscape architecture. This is a lead holder. When you press the stud on the end of the holder, it opens the pinions on the point, which hold the lead in place. This is the lead. Leads come in several different hardnesses. According to pencils.com, which I had to look up, the HB graphite scale goes from 9H, which is the hardest, and leaves the lightest marks, to 9B, which is the softest, and leaves the darkest marks. HB leads are at the middle of the scale and are good for general purpose drafting. F-grade leads are supposed to be sharpened to a fine point. I also have N2 leads, which are apparently a designation exclusive to, let's get that off the screen, hang on, which are a designation exclusive to Mars Statler and are suitable for drawing on film, I guess, apparently. This particular lead right here is, can we get it to focus? There we go. This particular lead is H, which is a little softer than HB. The harder the lead, the longer it will keep the point you put on it, which gives the lines you put on the paper more consistency. Consistency in line weights is important because the line weights, that is the thickness of the line on an architectural drawing, convey information about how the building is supposed to be constructed. This right here is a lead pointer. It is 2 parts, a container with a grinding burr inside, and a spindle in the middle, and the lid, which turns on the spindle inside. The lid has a couple of depth gauges that when you open the lead holder, drop the lead into the pit and move the pinions on the surface, thusly. I don't know can you see that? Probably not. Let's try that again. Drop the lead into the pit, move the pinions to the surface. We'll set the lead length for whatever sharpness of point is measured on the pit, or is marked on the pit. This one is a sharp one, this one is a duller one. The sharp one is longer. Pick your sharpness of point, set your lead length, and insert the lead holder into the long neck. There is a hole in the bottom of the neck that the lead goes into, or the lead goes through. Hold the container with one hand, hold the lead holder with the other hand, and run it around to sharpen your lead. This will leave lead particles on the lead, or graphite particles, I suppose, if we're being technical, which need to be wiped off before you start drafting. There are little fuzzy inserts that you can get to go in this hole on the lid to dip the lead into, but obviously I don't have one. A piece of paper towel or a soft cloth also work just fine. Hypothetically, one could use a mechanical pencil for this. The difficulty with a mechanical pencil is that because the lead of a mechanical pencil is uniform thickness, it's, about as thick as the tiny part of this lead, it will break more easily than a drafting lead, which is not a uniform thickness, which gives it greater strength or greater structural strength. A wood pencil is not a suitable tool due to the way you need to hold the drawing implement when you draft it, or when you're drafting, and we'll go into that later. So when you are drafting by hand, the efficient way to make refinements and revisions to your plan is not to erase and redraw. It is to lay another sheet on top, trace what you're keeping, and then draw clean what you are changing or adding. For this reason, the ideal medium is tracing paper. A roll like this is perfect for the rough drafts. The final draft, which you may wish to ink instead of pencil, and which would be presented to the zoning and permitting boards, and to your builder if you're not doing your own construction, is better presented on a higher quality transparent paper like Mylar or vellum. Something with a factory edge, a factory cut edge, looks most professional. You can use the straight edge on the drafting board to cleanly tear the paper with the right technique. That roll is trying to escape. What you do is you slide the paper up under the edge, up under your straight edge. Pull it out to the desired length. Press the straight edge against the surface of the board, and tear the paper. Clean and professional. You use drafting tape to secure the drafting paper to the surface of the board. You don't need a whole lot. The important part is to keep the corners down. And to keep the paper as smooth and flat as possible. Relatively square to the edges of the board is, of course, desirable. But not entirely necessary. And if you've got edges that are sticking up like I do here, you might tape them down as well. The tape you use should be sticky enough to keep the paper down but not tear it if you want to remove the paper from the board. They make specific drafting tape. It's not that dissimilar from masking tape. A word of warning: you do not remove the paper from the board until you are completely done drafting your plan. If you take it off, you will never be able to get it back on in exactly the same position, which will mess up all your measurements. Now, despite what I said about not erasing things, there are times when you will want to erase things. For example, if you want a dotted line. The best way to make one which is even and professional looking is to draw a solid line. You can almost see that there. And use the eraser shield to create even gaps in the line. A solid eraser like this is best used with the eraser shield. There you go, a perfect dotted line. A kneaded eraser like this is good for picking up stray graphite, cleaning the paper. You can also use stencils. There are various ones available. There are various ones available, especially for details, if those are called for on the plan. This particular one is 1/4" scale and has standard sizes, standard profiles for tubs, showers, toilets, appliances, and door swings here, or just general squares, circles, rectangles. This particular template is a 1/4" scale. Oh yeah, I wrote that scale on there wrong, didn't I? Anyway, the scales earlier I wrote were not entirely correct. So I'll have to fix that later. But this template is only useful at a 1/4" scale. So you can't use it for anything other than a 1 foot equals 1/4" plan. There are also useful symbols on this scale, like a north arrow, a bunch of other stuff that I have to review. And so that is useful for that. But this stencil just has circles, which you can still use for door swings or curved walls or pipe sections at various scales. If you need a curve that's larger than any one on the stencils, you can use a compass, a drafting compass specifically, with little lead points in it. The one thing that you should never do is attempt to draw a curve freehand. Because that looks unprofessional, and since this is what they call a measured drawing, every line has to correspond with an actual measurement in the real world. The last important item for now is a drafting brush. This allows you to sweep eraser crud or dust without smearing the graphite across the paper. Later we might talk about inking and coloring, and we'll go over the tools for those then. So the only thing we need in order to start drafting now is a set of measurements. Our first task will be to measure a building that already exists and create a plan for it on paper. So I will do that between now and next time, and then we will start drafting. This VOD will be uploaded to my second YouTube channel at Featherblade000, which is down in the lower corner of the screen, down there. If you have questions I didn't answer here, feel free to ask them in the comments there, and I will answer them either in the comments or in the next drafting stream. And this didn't take nearly as long as I expected it to, so I might actually play video games after this. But thank you very much for watching this, and I hope you'll join me next time. Have a lovely week. Good night.